The important change in Codex is not just a smarter model, it is that Codex is becoming a workspace for parallel software work. Instead of keeping everything inside one long chat, you create a project, launch focused agents, let them work in isolated repo state, and review the results. That changes the job from babysitting a single assistant to supervising several streams of work at once. The feature matters because it turns Codex into coordination software, not just generation software. The Codex app is the command center for that workflow. A project holds the context. Each thread tracks one task, and worktrees keep parallel changes from colliding. As each agent works, you can inspect the diff, leave comments, and decide whether to let the agent continue or pull the work into your editor. The value is not, it is clean separation between tasks, plus a tighter review loop between delegation and manual control. Skills are what make the system repeatable. A skill packages the instructions, resources, and scripts that a task usually needs. So the agent starts with the right playbook instead of rediscovering it every time. That is how Codex moves beyond raw prompting. You can encode how your team handles, deploys bug triage, design handoff, or asset generation, and use that same setup with other agents. In a multi-agent workflow, skills are the difference between parallel work and parallel confusion. Codex makes more sense if you think in terms of two working modes. One is the long horizon agent that can take on a larger task, run tools in the background, and come back with something concrete to review. The other is the live loop, where you keep steering in real time while the model works. Those modes solve different problems. One is delegation, the other. The product shift is that Codex is trying to support both without forcing you to rebuild context when you move between them. The model split reinforces that same workflow distinction. GPT 5.3 Codex is for jobs where you want the agent to do more on its own. It can research the codebase, use tools, make changes, and bring back a real handoff. Codex-Spark is about responsiveness. It fits the moments when interaction speed matters and you want to stay in a tight coding loop. So the question is not which model is universally best. The question is whether you need an executor or collaborator right now. One of the most useful parts of this workflow is that steering no longer has to wait for the final answer. The agent can surface progress as it goes, which lets you correct direction before it spends too much time on the wrong path. That matters even more when several agents are working in parallel. You need lightweight supervision, not a full interrupt and restart cycle every time something looks. Frequent updates turn multi-agent work from fire and forget into guided execution. The practical rule is to keep each agent's job narrow enough that you can judge success quickly. If an agent drifts, do not pile more instructions onto it. Shrink the task, split conflicting work into another work tree, or add the missing skill and context. Then review the diff. Either keep working there. Parallel agents only help when each one has a clean boundary and a clear outcome. The broader point is that this is being positioned as real engineering infrastructure, not just a demo surface. OpenAI describes teams using Codex for code understanding, refactors, migrations, testing, performance work, and incident response. Those are exactly the kinds of jobs where focused parallel agents can help. One agent can trace the system while another prepares the refactor or the test work. The multi-agent direction makes sense because it matches the shape of actual software work. The practical takeaway is to use Codex as a coordination layer, not just a bigger prompt box. Spin up separate agents when the work naturally breaks into clean tasks. Put repeatable team knowledge into skills, so every run starts from the right instructions and tools. Use the long horizon mode for background execution and keep human review at the end, because the system is most useful when it increases the amount of parallel work you can supervise without losing control.